Welcome back to another learning series with Mr. Knight. Today's topic is on the types of chemical reactions, and I want this topic to be in your mind forever. The types of chemical reactions that we are going to look at today include combination reaction, decomposition reaction, single replacement reaction, double replacement reaction, and combustion reaction. Now let's look at each reaction. Combination reaction, otherwise called synthesis or addition reaction, it is when two or more elements or compounds combine to form a single compound or molecule. It is typically represented with substance A reacts with substance B to produce substance AB. Now let's look at a very specific example. For example, sodium reacts with chlorine molecule to produce sodium chloride. Whenever you write a chemical equation, you must balance the equation and also try your very best to write the states of the substances. Now, to balance the equation, the atoms or molecules on either side of the equation must be the same. Looking at this equation, you'll notice the number of sodium, they are the same. However, the number of chlorine, they are different. Chlorine on the reactant side is 2, and chlorine on the product side is 1. Hence, you put a 2 before sodium chloride to make both chlorine equal. However, this 2 changes the value of sodium. Hence, to make the sodium equal, we place a 2 on the reactant side. Now, all the atoms and molecules, they are equal. The next step is to put the states. Sodium is a solid, chlorine is a gas, sodium chloride is a solid. Sodium chloride is a very useful substance in our everyday lives, and it is commonly called table salt. Let's go into another type of reaction. Decomposition reaction is when a compound breaks down into 2 or more simpler molecules. Generally, energy is required in the form of heat, light, or electricity. In the case of heat, it is called thermo-decomposition. In the case of light, it is called photo-decomposition. In the case of electricity, it is called electro-decomposition. Now let's look at the general representation. Substance AB will break down to form substance A and substance B. Now let's look at a very specific example. Now for this example, aluminum oxide, particularly this is named aluminum 3 oxide, will break down to produce aluminum and oxygen. Check if the equation is balanced. If it's not balanced, then put the numbers to make everything equal. In this case, it will be 2, 4, and 3. Those numbers are necessary to make this equation balanced. So it will be 2 molecules of aluminum oxide will produce 4 atoms of aluminum and 3 molecules of oxygen. The states will be, for aluminum oxide, it is a solid, aluminum is also a solid, and oxygen is a gas. Now let's jump into the other reaction. In single replacement reaction, it is also called single displacement reaction, and it is when one element replaces another in a single compound. a more reactive element will replace a less reactive element, and that is the key point. If the element replacing the other is not more reactive, then there will be no reaction. So generally representing this type of reaction is substance A react with substance BC, but I want you to notice something. Substance A must replace substance B. And in this case, substance A must be more reactive than substance B. So this now will produce substance AC and substance B. An example for a single replacement reaction is magnesium reacts with hydrochloric acid. Notice the magnesium must be more reactive than the hydrogen for this reaction to take place. And so the products will be magnesium chloride and hydrogen gas. To balance this equation, it requires a 2 right there. And then you want to put your states on. So magnesium is a solid. Hydrochloric acid is aqueous. Magnesium chloride will be aqueous for this reaction. And hydrogen is a gas. Now jumping on to another reaction is double replacement reaction. Double replacement reaction is also called double displacement reaction, and it is when two ionic compounds exchange cations or anions to form a new compound or new compounds. Usually water, salts, a precipitate, or a gas is formed. Generally representing this type of reaction is substance AB reacts with substance CD, and notice what is happening here. A and C are replacing each other. Hence, the products will be AD and substance CB. Now let's look at a specific example. Now for this example, barium chloride reacts with magnesium sulfate. The magnesium and the barium, they will replace each other. So this will produce barium sulfate and magnesium chloride. Look carefully and decide if this equation is balanced. Absolutely. And so definitely some equation, they automatically balance out as you write them. And so the state for barium chloride is aqueous. Magnesium sulfate is also aqueous in this case. And barium sulfate that is produced is a solid, so it will be a precipitate, and magnesium chloride is aqueous. Now let's jump into our other type of reaction, which is our last reaction, but a very important one as well. Combustion reaction, otherwise called burning, is when substances react or burn in the presence of oxygen to produce energy. The energy is usually in the form of light and heat, and this is very important in our everyday lives. This is happening in our cars and also in our home. The general representation for combustion reaction is that substance A reacts with oxygen to produce carbon dioxide, water, and energy. Now let's look at a specific equation or reaction. And so in this case, we can react methane with oxygen to produce carbon dioxide, water, and energy. Check and see if this equation is balanced. If it is not balanced, then we balance the equation by placing the numbers at the appropriate molecule or atoms. Now, This is a state of methane, which is a gaseous substance. Oxygen is also a gaseous substance. Carbon dioxide is also a gaseous substance. And the water will be in the form of vapor in this case, since the heat will be high. And of course, we get our energy. My gentle people, it was an absolute pleasure to present this to you. So let your reactive power be strong until we meet again.